iConnect 54 event on climate vulnerability and adaptive practices. Just briefly, I will tell about this event. This event focuses on understanding the impact of climate change on various ecosystems. For example, Himalayan region, Gangetic Plain, coastal region, and islands, and sectors through the lens of vulnerability. Post 2021, the world may face diverse challenges like loss of biodiversity, ecosystem, services, and rapid urbanization. To mitigate and adapt to these challenges, it's important to understand the vulnerabilities of different ecosystems, communities, and industries to the present and future challenges in climate. Now I will briefly introduce the speakers and panelists, and then we will start with the presentations. So first speaker is Professor Kalachand Sen, Director, Wadia Institute of Himalayan Geology, Dehradun. Dr. Kalachand Sen's main research interests lie in delineation and assessment of gas hydrates, imaging subvolcanic sediments, and understanding geotectonic and earthquake processes of Indian provinces, including the Himalaya, from geophysical data. Then Professor Dr. Sanjay Narayan Patil, he is head Department of Applied Geology, North Maharashtra University, Jalgaon. Dr. Patil's area of expertise include engineering geology, hydrology, geohazards, environmental geology, and medical geology. His current focus is on water quality and geomedical health hazard managements. Dr. Amir Bazaz, Namaskar sir, welcome to this I-54 event. So Dr. Amir Bazaz, Associate Dean, School of Environment Sustainability, IIHS Bangalore. Dr. Bazaz area of interest encompasses issues at intersection of economics, climate change, mitigation, adaptation, and sustainable development, low carbon societies, and infrastructural urban climate change, linkages, and climate, energy, and environmental policy. Then we have Professor Dr. Shyamasri Dasgupta. Dr. Dasgupta's expertise lies in energy, environmental economics, economics of climate change, applied econometrics, climate relevant vulnerability of the Indian Himalayan region. And we have Professor Dr. Bhaskar Sinha, Associate Professor, Chairperson, Center for Climate Change Studies, Indian Institute of Forest Management, Bhopal. Dr. Sinha's interest lies in climate change adaptation and mitigation, sustainability, integrated natural resource management, biodiversity conservation, and livelihood, and interface between social and ecological issues. Then we have Mr. Panelist, Mr. Rahul Kapoor from Ministry of Housing and Urban Affairs. He is the Director of Smart City Mission. Then we have Professor Nabeen Sharma, Dr. Nabeen Sharma, and his expertise in energy, conventional and non-conventional energy, Department of Energy, Tezpur University. Also, we have panelist Miss Suruchi Bhadwal, Director, Earth Science and Climate Change, TERI. So to begin with, may I request now Dr. Kalachand Sen to take care, and I would like to request all the speakers to follow the timeline so that we can be in time, we can conclude this session in time. So Professor Kalachand, the dais, it is yours, sir. Dais is yours. Please present, sir.
My slides are visible.
Yeah, it is. Yeah, now it is visible, sir.
Very nice, and thank you very much, sir, for giving a brief introduction onto this program. And I have taken a topic of development of artificial intelligence-based integrated warning system for mitigation of geohazards, and taken one example from Uttarakhand Himalaya related to glaciers and glacial lakes. So if we look into the scenario into the Himalaya, this is the world's youngest and most rugged Himalayan chain that has formed by the collision between Indian and Eurasian plate about 50 million years back. 2,500 kilometer long, west to east, 300 to 250 kilometer width, south to north. This Himalayan region is fully stressed by several processes going on below the surface as well as on the surface, such as convergence, exhumation, deformation, tectonics, neotectonics, and erosion, weathering, and precipitation. These stress have been further aggravated by the climate-induced stresses like excessive rainfall or warming, anthropogenic impact like construction of the buildings, ropeways, tunnels, mining, etc. So all these processes have led to the changes into the landscape and geomorphology of the Himalaya, which in turn control the damage pattern whenever there is an earthquake, there is a landslide, there is an avalanche or flash floods. And millions of people living into the Himalaya and adjoining region are affected by this. And whenever disaster takes place, they lose their lives, livestock, properties, structures, and economy. So under the Prime Minister's 10-point agenda of risk reduction, it is our customary duty to build a disaster-free society, a climate-resilient future for sustainability and secure living into the Himalaya and adjoining regions. So that's why this subject is very, very important. There are so many disasters related to earthquakes, related to avalanche, related to landslides. But today I'll be touching only upon the glaciers and glacier lake related hazards. When you talk about glacier, what is a glacier? We know that Himalayan high altitude and at the altitude temperature is very low, below zero, and a big mass of ice formed by the compaction and decrystallization of the snow because of its gravitational force is called the glacier. And any lake formed into the high altitude due to the glacial activity, we call glacial lake. So these are extensively observed into the high altitude of the Himalaya, particularly in the Indian Himalaya. And the lake can be formed, we can see at the front of the glaciers, or it can be formed at the side of the glaciers, or it can be formed below the glaciers or over the glaciers. So some examples I have shown over here. And if we look into the Indian Himalayan region, Jammu, Kashmir, Himachal, Uttarakhand, Sikkim, and Arunachal, we have roughly 10,000 glaciers and 20,000 glacial lakes. They have covered around 37,500 square kilometer area. Even if we look into only in Uttarakhand, we have 1,000 glaciers and 1,500 glacial lakes. Why you are so much concerned about the glaciers and the snow fields into the high altitude of the Himalaya? Because they feed the Himalayan river systems and they are the lifeline to billions of people living into the Himalayan adjoining region for their drinking water, for irrigation, for hydroelectric power generation, even industrial usages, domestic usages. The water and sediments coming through the river, the transmit have made the attractive the Himalayan state center stage for the settlements, for their socio-economic development, socio-cultural development, socio-agroeconomical development. So these are very, very important. And we have seen that this region is one hand associated with a lot of geohazards, and other hand, it has a lot of resources, particularly it is called the water tower of Asia, and that water is huge quantity into the Himalayan regions. So we can see that Himalaya, in one hand, associated with the hazards, and other hand, full of resources, and the resource is so useful and useful for our everyday life or day-to-day life. We cannot avoid that scenario. So what exactly happening into the high altitude glaciers? I am giving some of the examples that glacial lakes form into the high altitude can be done by the ice dam, can be formed by the landslide dam, can be formed over the bedrock, can be formed by the moraine dam lakes. So if you take one example of a lake situated at the high altitude, and this lake will have its capacity for the accumulation of the water. That water can come from ice melt, they can come also from different other sources. There may be some sort of precipitation, that solid precipitation, liquid precipitation. There will be tectonic forces because Himalaya and this lake existing into the Himalayan belt, which is tectonically very active. There can be avalanches, there can be landslides. So many phenomena can make some sort of impact to the lake, and the lake water capacity will not be sustained by the lake volume or the lake area itself, and the water can overflow and it can come down heavily because it is lying into the high altitude. Its slow region, it come out heavily and can wash those villages, temples, pilgrimages, etc. Or even the water cannot, that wall of the lake is formed by the loose debris material. They are not solid material. The wall also can be breached and that can cause. So that's why they generate the flash floods and cause huge devastations and catastrophe to the people, to the structure, to the any other livestock lying into the downstreams. So we need to monitor what exactly happening to the lake. We need to monitor what exactly happening to the glaciers. And we have different sets of data, that satellite data, remote sensing data, and we can understand what exactly happening to the fluctuations of the lake volume of the water and the lake area, glaciers area, snowfall precipitation, water sediment discharge, stream velocity, and the number of the glaciers and moraine, what exactly their health over a period of time, maybe 20 years time, 25 years, 30 years time. And these are the concern under the present climate change scenario, because we have seen a lot of impact of the upstream climate change to these downstream structures, hydroelectric power projects, and they are having a lot of impact by the glaciers and glacial lake related hazards. So I'll give you an example. In the Karakoram region, we have mapped by the Wadia Institute what are the globs. Globs means the glacial lake outburst flats. And this is the spatio-temporal distribution of the globs. And most of the glacier into these regions, lake, are ice dammed. So they have some sort of affinity to easily break down and cause devastation in the form of glob. But if we look into the glacial lake, into the Uttarakhand, and into the Himachal Pradesh, where we have 958 lakes, and in the Uttarakhand we have 1265 lakes. These are the moraine dam lakes. So they will have more stability than the lakes into the Karakoram region. But still, we have found out a lot of catastrophe due to the glob into these regions also. If you look into this example, 2013 Kedarnath, that glacial lake, this was before the disaster, and then because of the recession of the glaciers, because of the moraine failure, loose sediments, continuous rainfall, the glacial lake outbursted. And this impacted hugely to the Kedarnath temple. They killed 6,000 people, inundated 5,500 villages. They affected tourism, ecosystem, they damaged building, bridges, and more than 1 lakh pilgrims were trapped into the regions. And these are evident by several sorts of study. If we look into the seismic noise, if we look into the large boulders, sediments, meteorological data, hydrological data, these impacts are arrested. But if we want to monitor them, we should have hydrological data, we should have meteorological data. Mostly we are depending on that. If we look into the another glacier, in the Gangotri glacier, then we can find out that if we look into the snout or mouth of the glacier, and over a period of time, 1965 to 2017, this work was published in 2019, then we can see the glaciers are retreating. And this we have observed that at a rate of 15 to 20 meter per year, the glaciers have retreated. And into that process, what exactly happened? There was a stream, and this stream have widened. So we have continuously monitored the data by looking into the glacier's health, by looking into the elevation change. And if we look into the elevation change into this path, what we have shown over here, then we can see this is the path where we have seen the depositional area, and this is the path we have seen the erosional area. How can we do that? If we look into the elevation of 2014, that has been shown by red color, and if you look into the elevation 2017 blue color, then you can see the difference of elevation, and from there we can understand that how much area have been eroded, how many area have been deposited. And this deposition area is obvious. When it's retreated, lot of water started flowing down, and sediments they got deposited into this down. So that's why it has been deposited into this area. So these two phenomena took place into the summer. But if we want to monitor, how we'll be able to monitor what are the implications to understand how they're changing their area. So if we look into the change into the lake area and change into the area of the glaciers, then we can see from 1991, 2000, 2015, the lake area is getting enhanced and the glaciers have been sinking. Similarly, here also we can see the lake area expanded and glaciers sinking. Into the Sikkim between 1991 to 2015, we have observed that 23 glaciers have lost 5.4 percentage area, and the glacier lake area have been increased by 48 percentage. These are concerns, because if it increases like that, after certain time, it will not be able to sustain that water, and it will cause some sort of devastation in the form of flash floods or bluff into the downstream. But if we look into the last year, Rishiganga Dhaliganga flash flood, that was mainly caused by ice rock avalanches. The two examples I showed earlier into the Gangotri Glacier and the Kedarnath, they took place during the summer. But this one took place into the peak winter. So what are the mechanisms of all these phenomena taking place? Any time of the year, it can take place. And particularly the ice rock avalanche took place into the winter in the Rishiganga, Dhaliganga, because of multiple factors. Recession of the hanging glaciers, geology and lithology played a very important role, loose sediments, and climate variability. And we have seen their impact by observing that around we lost 200 people. It damaged hydroelectric power projects, road, bridges, affected ecosystem and tourism. But before this event, we didn't have much idea that how this seismology data can be useful to understand the processes of the avalanches. Fortunately, we had a seismic station near to the Tapovan region, and which is close to the nucleus point of the rice rock avalanche, around 12 kilometers away. And into that data sets, when we did post-mortem, we found out the entire episode of the ice rock avalanche, starting from the nucleation and the flow of the debris and advancement of the flow, and how did it make impact to the hydroelectric power project, damage roads, bridges, at what rate the debris flow moved. All these phenomena we have seen by marking T1, T2, T3, T4, T5 event. And when we analyze this seismological data into their frequency spectra, each event was arrested. So that shows the seismological data can be used to understand the processes. And we have published some result into the scientific report, into the science, as well as our local journals. But what are the main causes took place into the winter? When we look into the image into that area, we have found out that this particular rock is made up of weathered, highly weathered granite, mica schist, and micaceous quartzites. And there were a lot of joints. What exactly happened into this region? Because of the recession of the glacier, the basement over which glaciers were lying got exposed. And the basement rock, what is I told already, garnet, mica schist, micaceous quartzite, they were exposed to the heating and freezing around the year, when the winter and summer, and they got developed some sort of fractures and cleavages. And through the fractures, the rock or ice melt entered, and in the summer and the winter, it got frozen into ice and they expanded. So fractures, all these parts were much more opening. And this additionally, before the event took place on 4th and 5th February, from the IMD report, we have seen huge accumulation of the snow. So if we look into the cumulative effect of weathering, crevasses, snowfall, which has led to the detachment of the huge volume of rock and overlying hanging glaciers that fell down, approximately 27 million cubic meter volume, fell down from a height of 5,600 meter to 3,600 meter. When it fell down, got fragmented into pieces, and they created water. If we look into the previous data in the Google Earth image in 2016, we found in that bed there are some sort of dead ice, and there are some sort of other material looking in, placed into the Ronki flow. So when all this material came down heavily along the heavy slope region and overlying previously accumulated dead ice and debris water stuck into the valley, it took en route. And since it is the slope region, it came down heavily in the form of the slurry material. And when it blocked the water into the Rishiganga river, it created a small lake. And the further flew down into the Dhaliganga. And when it fell down to the Dhaliganga, it created so much impact that the water receded back. And it came down as a tsunami, and that impacted Tapovan hydroelectric power project. 200 people are working. They could not be saved because we didn't have warning system. It damaged that particular hydroelectric power project, etc. So many things happen into these regions. We understood from the study. Till date, by looking into the remote sensing data, we found out that this area is getting subsided, and there is a toe erosion. So we are having some sort of fear that this region may experience some sort of landslides. So we need to understand the process going on into the region by looking into the debris flow simulation model and mass movement model, so that by looking into the high resolution satellite data, we will be able to understand more what exactly happening into this region to save the people, to remove the fear of the people that they are going to experience some sort of landslides into these regions. Mostly, we monitor the glaciers and glacial lakes by looking into the hydrological data using automatic water level recorder, by looking into the meteorological data obtained by the automatic water stations, and then from the glacier recession, mass balance, sediment, discharge, water discharge, temperature, humidity, wind speed, wind direction, we give some sort of monitoring effect. But in the recent study, after the Rishiganga, Dhaliganga disaster, we did post-mortem and find out that before the main event, there are a lot of tremors and spikes, and this we consider as precursor to understand or give some sort of warning that something is going to happen into these regions. So what we propose, that we have to establish a network of hydrological stations, meteorological stations, as well as seismological stations. And from the stations, the data will be transmitted to a centralized place where we will be processing and modeling the data based on artificial intelligence, integrating the data, and provide some sort of warning system into these regions. But we have already said that in the Himalayan region, so many glaciers, so many glacial lakes. So which glacier we should monitor? For that, we have chosen one important glaciarized basin near the Dhaliganga and the Ganga.
Sir, excuse me, sir. 2 minutes more to go, sir.
Yeah, I'll finish it by 2 minutes. So in these glaciarized basins, we see every year there are a lot of pilgrimages, Badrinath, Kedarnath, Gangotri, Yamunotri. So keeping in that one in mind, as well as in these basins, we have seen there are 16 constructed hydroelectric power projects, 13 under construction, 54 proposed. So they need attention so that we can avoid in future some sort of damage into these regions. So what we have proposed into these regions, that where we'll be setting up a set of instruments which will be getting the real-time meteorological data, hydrological data, and seismological data, as well as the satellite data, by which we'll be able to understand many phenomena to the health of the glaciers, to the health of the glacial lakes, and we'll integrate them 24/7 based on artificial intelligence by reducing the human intervention and develop the integrated warning system into these regions. So if we have this sort of set of data, then ultimately this will provide as a tool or process for mitigating the impact caused by the glaciers and glacial lakes hazards into these regions. And once we are successful in one basin, that can be developed and easily deployed in other glacialized basins. Thank you very much for your kind attention.
Thank you very much, sir. You have finished your presentation in time. I'm really highly obliged to you, sir, for this. You have nicely covered the vulnerability aspect, particularly the impact aspect you have covered through the scientific analysis. For example, the stresses, what you have narrated, the stresses by subsurface complex processes, and you brought out the glacier related hazards. Of course, I mean, its impact on these resources, particularly the life resources in a Himalayan region, the water, energy, all these aspects. And what more appealing is, it's not just the summer, I mean, flash floods, but the winter also. I mean, on the both the time scales, globes and flash floods, we need to really closely monitor. Thank you so much, sir. We'll come back to you, sir, for this panel discussion again with some questions. Now I invite, thank you so much, sir. So now I invite Professor Sanjay Narayan Patil for the talk. Please, sir, Patil, sir.
Yes, sir. Good morning, sir.
Yeah.
Good morning to all. Today, my topic of discussion is on impact of climate change on groundwater vulnerability, issues, opportunities, and challenges under Azadi Ka Amrit Mahotsav celebration. I connect ICN 54, climate vulnerability and addictive practices. As we already know, Earth is one of the planet in the solar system where life is exists before 1 million years. And Earth is made up of a system which is called as so there are four systems that you call as lithosphere. Land stands for lithosphere, water stands for hydrosphere, air stands for atmosphere, and life stands for biosphere. All these four elements are interlinked each other. If any one degradation is there, then we can say as there is an environmental degradation, and it's adversely impact on the environment, various natural resources, and all the ecosystems. That's why we must understand the earth system, and that's why we are dealing with the geosciences. It involves the understanding of the constituents of four elements, and the results of these four elements are they are interlinked each other. That's why earth system we must understand. And if there is a changes in the process, then we can say as there is an environmental degradation. There are two types of processes, mainly surface and subsurface process. Whereas ability of the earth to withstand the process, in surface process, we can say as formation of landforms. In earlier days, in peninsular India, many rivers are perennial, but now many streams or rivers are not perennial because of formation of changes in the landforms, evaluation of land and water. Whereas subsurface method leads with the volcanism, earthquakes, and tsunamis, and their adversely impact on the environment and various issues. And this is happened because of isostatic imbalance. Nature is always maintaining their ratio of balance, but if there is a changes in the process, we can say as isostatic imbalance. Now there is a need to where to look the issues of surface and subsurface process for the societal being. Now there is a need to integrated research to be carried out for the benefit of the human being, that is known as natural resources, water, mineral metals, and fuel crisis. We are exploring these natural resources and their adversely impact on the environment. So we are stressing today on water resources. Everybody knows about 71% of the earth's surface is covered by water, and out of which 97.1 is total water is in ocean, where distribution is remaining 2.9 is very uneven. Now we have a 0.61 and 0.001% water is available in entire the globe, and we are managing these resources for our needs. As far as Indian scenario is concerned, in India, 69% of irrigation is groundwater dependent, out of which 92% population uses groundwater for drinking purposes. So everybody knows about the droughts in many peninsular Indian states. As we this is the Maharashtra state, 36 districts, total area is 30.77, which is third largest state in the Maharashtra. And this is physiographic division map of the Maharashtra state. In eastern side, we are having Eastern Ghats, and in western side, we are having Sahyadri ranges. And Maharashtra is having 15 river basin, whereas Tapi, Godavari, Bhima, Krishna, these are the major river basins in the Maharashtra. And most of the districts, they are suffering the droughts everywhere because of unpredictable fluctuation in the rainfall. This is the average rainfall trend of the Maharashtra. In western side, we are receiving maximum rainfall more than 3,000, even though in Mahabaleshwar we receive the rainfall near about 5,000 millimeter. And where is move towards the northeastern or northwestern side, rainfall is decreases. So, and this is the hydrological cycle. We are understanding this particular cycle right from our childhood, but still the mechanism of hydrological cycle is very much important because of unpredictable fluctuations in the rainfall. As we are having three seasons, but in rainy seasons we are having 4 months, but we receive the rainfall in unpredictable manner. That's why if you see, they consider the regarding evaporation, transpiration, and infiltration regarding the hydrological side. There are many problems in Indian shield as we are observing in this particular slides. If you look towards the Maharashtra, 85% of the Maharashtra state is covered by Deccan basalt, and rest of the part is covered by other formations. The Deccan basalt is a very hard rock formations, and among these, we are having different localities, areas where we have to study the main aspects: groundwater management, watershed management, water pollution, agro-based problems, and environmental issues. These are the problems arises in many parts of the Maharashtra state, as well as wherever the hard rock is available in Indian shield. These are the problems arises. In summer season, we are facing the problem of drinking water crisis. In another side, water is using for cash crop like banana, sugarcane, orange, grapes, where salinity problems are also there in many parts of the state. If you look towards the dug well, there is no dug well to observing today, but we are having a huge water level depletion day by day. If you look towards another sides, farmers are waiting for the rain, but there is no rain, and droughts are there. The insufficient growth of the crops because of insufficient rains, and these are the two main activities. Afforestation means, if you look towards the Satpura ranges, in as per norms, we must have 33% of the total land forest, but in real scenario, forest is less than 20%, and there is a degradation of forest is adversely impact on the environment, and it causes many problems to the water resources point of view. If you look towards the sand mining activities, sand is having holding capacity of water, but due to the huge sand mining, illegal and legal, there are adversely impact on the water resources. This is about the one article in the local newspaper regarding forest. The forest is less than 10% in overall the North Maharashtra region. It adversely impact on the environment. In three decades before, the average temperature of Jalgaon district is 38 to 35 to 38 degrees centigrade. In present scenario, the temperature is greater than 45 degrees centigrade. This is an adverse impact on the environment. These are the sand mining activities, manual and automatic, whereas automatic suction pump is banned by NGT in Maharashtra. And due to the sand mining activities, if you look towards the well, there is no water in the well because of sand is having holding capacity of water, and if there is no sand, then it adversely impact on the aquifer properties of the rock. It reduces the scarcity, is causing scarcity, runoff increases, agriculture production is badly affected. It may disturb the hydrological cycle, causing late monsoon also. These are the, and widening of the river banks, loss of the fertile soil in the fields of the banks. These are the various impacts on the environment. It reduces the porosity, it reduces the permeability, and rock is exposed on the surface, and water is just like as a evaporated tank. And cracks are developed nearby the farming, and it badly affected the production of the grains and whatever the crops are there. So it adversely impact on the environment. Soil erosion is there. These are the various impacts of sand mining activities on the hydrological cycle as well as the water environment. And it also adversely impact on the pumping water supply schemes near in the river or bridges or any permanent civil structures. It adversely impact on the environment. Regarding the watershed management, if you look towards the North Maharashtra region, many in Dhule and Jalgaon districts, total 14 watersheds are overexploited. It clearly shows that there is huge exploration of water resources for cash crop like banana and sugarcane. If you look towards the case study of Dhule and Jalgaon districts, water level is declining day by day, and water fluctuation, rainfall is also unpredictable fluctuations adversely impact on the water level. This is the trend of Jalgaon and Dhule district. A similar trend is observed in other districts also in Maharashtra state. If you look towards the dug well and the depth of a well, right from 2 decades, the well depth is increases because of water level is also increases. This is the comparison between depth of wells and water level. And we have calculated the on the basis of geophysical techniques, we have calculated the unsaturated granular zones, uh, because they are in earlier days the unsaturated granular zone is having aquifer, but nowadays water level is declining day by day. There is a huge potential of recharging the water resources. On the basis of this, we have calculated the average thickness of unsaturated granular zone, and if you uh, compare the rainfall and estimate the total runoff, if and out of which 50% dependability, if runoff is arrested in the unsaturated granular zone, then some of the problem may be solved, because surface runoff, if we can recharge to the unsaturated granular zone, then it helps sometime. This is an one of the aerial photography interpretation and suggested some uh, recharge zones in a Jalgaon district. Regarding the summary of groundwater assessment, it clearly 50 years data, which clearly shows that there is an dark zone, means it 100% overexploited watershed in some parts of the Jalgaon district. This is a general trend. As demand is increases day by day, rainfall fluctuation is also there, and water level is declining day. During 99, we observed the rainfall is very at negative level. It seems there is a huge exploitation of water resources for cash crop like banana and sugarcane. In another side, we are looking towards the qualitative problems. The area is having also hardness is there, and we are also analyzing the water resources for irrigation purpose. If you look towards the agro-based problem, the many parts of the many districts in the Maharashtra, they are consuming the chemical fertilizers for growing the production of sugarcane, banana, grapes, orange, like that. And Jalgaon is one of the highest consumer of fertilizers, and it adversely impact on the water environment. Means nitrate concentration is observed in this particular area. And this is one of the case study of major research project UGC, environmental impact of municipal waste on the water environment. This is total 48 MLD wastewater is generated, and they are discharges into the different nalas nearby the Jalgaon Municipal Corporation. And if you look the analysis of the total, the cadmium and lead is concentrated in groundwater, and it adversely impact on the environment. And in that, we have prepared a geolytic bed model, and this is pilot laboratory based model we run, and it clearly shows that this is the characterization of geolites, and it clearly shows that heavy metal is the analysis of the heavy metal shows that reduction in the nickel is 97.32%, followed by zinc, lead, and chromium. And this is the before treatment and after treatment. After 3 hours and 6 hours, the analysis of heavy metal shows the first 3 hours approximately 50% reduction of the heavy metal concentration was observed, which leads to 90 to 100% reduction in the next 6 hours in case of cadmium, nickel, and zinc. This is another project funded by NASIC. Here we conducted the water quality analysis of Nandurbar district, which is a tribal district of the Maharashtra state. It clearly shows that there are certain problems, water quality problems in the Nandurbar district. Nitrate concentration and hardness is there. It adversely impact on the human health. The waterborne diseases are there, kidney stones are there, many heavy metals are concentrating in this particular district. Again, we further move the geolytic bed model in the form of aquaguard like system. We have used the natural geolites as a purifying agent in the laboratory scale. Then we conduct this particular program into 4 villages. It clearly shows that fine sand bed oil and geolytic material. This is the pilot bed model. It clearly shows that many alkalinity is reduces 61%, total hardness is reduces 81%, TDS is reduces 69%. Means these are the different models we prepared, and it clearly shows that this natural zeolites are very much purifying agent for the hardness, TDS, and many elements. And we have created awareness campaigns in Nandurbar districts, and you have performed this particular experiment in 4 villages in Nandurbar district under banner of Nasi and their health impacts. Again, we have conducted one more aquifer mapping studies in Chopra inlier areas, that we have prepared aquifer disposition model in Piedmont zone, alluvial zone, and basalt zone. And this particular aquifer mapping, which clearly helps us to understanding the behavior of aquifer 1, aquifer 2, and aquifer 3, which is in Bazada zone, alluvial zone, and Deccan Trap zone. And it helps us to recharging the how water resources into the aquifer, which is a overexploited water in this particular belt. And these are the certain locations proposed by artificial recharge or suppression of injection into the alluvial zone. And this is another case study we conducted in Raver part of the Suki Basin area. And we have shown that the priority wise, the poor zone, moderate zone, and good zone in this particular zone. And it helps us for delineating the aquifer parameters and suggested some artificial measures in this particular area. Again, we conducted one more program in a particular one village. We conducted one trench over there, having different models, and in next season, water level is increases after treatment, showing the trend. Another participatory approaches we also conducted with the help of NSS students as a program coordinator, and we have constructed 2 bandaras in particular, and it helps us the nearby downstream side of that Sauda village is having their dug well of water supply. And uh, it helps us to the villages for construction of 2 bandaras, and water level is rises in that particular. In mining sector, we also suggested some
2 more
recharging
minutes
trench.
are left, sir.
Yes,
2
sir.
more minutes.
As a token of appreciation, there is letters and certificates of this particular thing, and it helps us to the societal issues. If we see the figure, it's an ideal figure. It's an ideal watershed development program. If you look towards the figure, it helps to ecological balance and maintenance is there. Then from foregoing discussion, it clearly indicate that the natural resource is essential key to understand, overcome this problem, which is the need of the time and ultimate benefit of the society. Whatever the findings and observations are likely to be practical importance in the groundwater resources for well-being of the society. Thank you, sir. These
Thank
are
you.
the certain
Yeah.
remedial measures: water auditing, environmental audit, changing cropping pattern, change of the mindset, rooftop rainwater harvesting, and finally plant one, teach one, each one for saving our environment. Thank you, sir.
Thank you. Thank you so much, sir, for keeping the time. Thank you so much. You have nicely elaborated on the environmental degradation issues and scientific assessment to surface, subsurface processes. Also, you have covered the isostatic imbalance, how the isostatic imbalance lead to this environmental degradation. And water resources distribution also, those issues you have covered. Particularly the variation in rainfall distribution across the Maharashtra state and exploitation of natural resources. I mean, this and how it affect the water management actually, particularly the soil erosion also. So this exploration of watersheds also you described how the exploration of this watersheds are being are being executed. And this another thing is this water quality analysis. The main important thing is the water quality analysis you covered, and treatment for this water quality. I mean, how to improve the water quality. The treatment also you have suggested, particularly the your this campaign, awareness campaign among this tribal region. That is really useful, I think, for the societal benefit. And aquifer mapping, what you have suggested, For the, I mean, dealing with the recharging issues, that is also an important thing. Thank you so much, sir. We will come back to you for this during panel discussion. Now I invite Dr. Amir Bajaj. Dr. Amir Bajaj, please.
Yes,
Yeah.
Miranji, good morning, and also good morning to other speakers. Thank you for inviting me to this meeting. And also, I'm very delighted to be in the august company of so many eminent speakers. So, thank you for this opportunity. I will be very brief. I have a presentation. My presentation is not specific to any issue, but it broadly derives from climate adaptation research that I have been doing for the last nearly more than a decade. So I felt that it will be useful to talk about what are the key takeaways from our research, which may be helpful for informing or giving advice to young researchers, and also beneficial for positive policy outcomes. So I will now share my presentation and take the participants through. Is my presentation visible?
Yes, sir. Yes, sir. Yes, sir. You may put it in full screen.
I will put it in full screen. Uh, is it visible?
Yes, sir. Yes.
Yes. So, what I'm trying to inform the audience here is about three or four broader issues that we need to be mindful of if we are thinking about anything related to climate adaptation. Uh, uh, the first issue or matter of inquiry is focused on my work looking at rain-fed agriculture in Karnataka. So, and we know that farmers are dealing with a lot of risk and uncertainty on a daily basis. But many farmers have also leveraged these kinds of uh, challenging situations to innovate. And what we did in
We
one
are
of
not
our
able to see the screen fully. Something has been. All of us can see the screen fully.
Yes, sir.
Yes, I can see. Yeah.
Yeah, I am able to see.
Yeah,
I am
yeah.
able to see.
I will all anyways share this with Milan ji, and he can circulate also later.
That's fine.
But
Yes.
Thank you.
yeah, thank you, thank you. So, so Karnataka government, what it does is that it has been running a program where it recognizes farmers' efforts, and so what we did was that we systematically identified some of these farmers, went and met them, did detailed interviews, and our intention was that if we are thinking about scaling innovative practices ground up, what are the lessons that we can draw from such an interaction? And also, what are the barriers that of the farming community in general, from an innovation perspective, are, are being faced? So, our intention was that, okay, what can we learn, and how can we scale innovation, and then how can we also systematically look at some of the barriers? And this is uh, uh, one piece of research based insights that I'll be talking about. So I will not go into the details of what this award programs are and is and how marks are given, but essentially this award is looking at six broad categories. Water is an important focus area, so how water is being judiciously used. Organic farming is one aspect. How farmers are examining peer-to-peer learning and knowledge transfer. Uh, what kind of innovation is happening? Uh, uh, is it about quality? It is about quantity of produce? And what's the implication of this innovation in terms of ease of adoption and low cost? What's happening in the domain of genetic conservation? And what are the other sustainable practices being followed by farmers? So these are the issues, enablers of innovation that we found. Mm. The first point is that personal farming experience and then coupling it with whatever institutional, non-institutional knowledge platforms exist. Leveraging of this is an important enabler. Uh, uh, for example, there are many capacity building initiatives by the government and civil society. So there is some kind of coming together of these personal experiences and then getting it complemented by these platforms. That has significantly enabled scaling of knowledge. Second is that wherever we went, we realized, and this is a very important policy perspective, that farming alone is difficult to sustain lives in rural areas. And therefore, whosoever we spoke to, farmers, these progressive farmers, they are called progressive farmers, they have carefully looked at how they can also diversify on livelihood. So to ensure that there is an alternate source of income. Third is peer-to-peer networks and its existence to facilitate exchange of knowledge and information uh, uh, is an important enabler. So these are either facilitated by the government or this is facilitated by civil society actors. And the Krishi Vigyan Kendras have played a very crucial role in facilitating these conversations and exchange of knowledge. Fourth is institutional support helps. So if there are schemes which dedicated to it's kind of aimed at agriculture, horticulture, or rural development, they have been helpful. There have been challenges around uniformly accessing these, making these accessible institutional support schemes, but civil society actors have been playing a good role here. But this has definitely been an enabler because there is an opportunity where some kind of risk sharing exists and farmers have positively looked at these. Finally, which is an important element which I'll come back, is there's these there's this new term that has come up very strongly, which is knowledge brokers. So, uh, not in a negative sense, but there is an intermediary in the knowledge domain that exists at the local level, which is basically consolidating knowledge. It's also facilitating peer-to-peer learning. It's also becoming a platform through which knowledge is getting disseminated. And these progressive farmers also come there and become a part of that network. So there's a positive role of, for example, Krishi Vigyan Kendras in facilitating innovation and also giving some confidence to individual farm level innovation. Now, the barriers uh, and needless to say that barriers exist. India is a big country, huge country. There are different kinds of challenges, but uh, what is the barrier to innovation? Of course, these barriers are at two levels. One is that very structural, that there is farming is becoming increasingly difficult for obvious reasons, that water is a problem and land degradation is a problem, and of course government is also making every effort in terms of alleviating these situations. But some of the typical things that's like kind of blocking innovation or bottom up innovation, One is one is that organic farming entry barriers are still high. For example, there's this market connect which is still evolving. Um there's also some delay between adoption of organic practices and how the profits emerge. There's also discrepancies between the price of organic versus conventional crops, which is kind of market linked, but also becomes some kind of a dissuading incentive for farmers. And of course, all of this boils down to that the cost benefit schema doesn't work. So there's delay in financial returns. The second aspect is sometimes institutional support is a little inadequate, but I think this is a learning by doing domain. There are subsidies, there's infrastructure support, there's technical know-how available, but um, it's more about making it accessible. KVKs are doing a good job, and we have to continuously think carefully about how do we expand and extend institutional support. And of course, some of these activities are labor intensive, and as we know, and others in the panel will also attest to, uh, farming is difficult, and there are now other opportunities available in nearby cities. So it's farming is not very attractive anymore, and some of the initiatives and interventions are quite labor intensive, and either there's no labor or there's high labor costs. And of course, some amount of mechanization is happening, which these farmers are also innovating around, but still these are human intensive processes, and labor and high labor costs are definitely important barriers. Nevertheless, there are the benefits of such things or such interventions have been phenomenal, and we need to systematically look at this. And of course, linking back to the agenda of how can we improve or enhance rural incomes. Uh, Coming to this issue of knowledge brokering, and I went around the country, spent some time in the northeast, and also spent some time in the arid areas of Rajasthan, and spoke with a lot of civil society actors who are actually working with local actors, local communities, and either uh, becoming some kind of an interface between modern scientific knowledge and local community based knowledge. And I think their role is emerging to be substantial in terms of bridging the knowledge gap, and also facilitating the benefits of modern scientific knowledge going to the community, and ensuring market linkages and all kinds of activities. And we found that this kind of knowledge interaction uh, is crucial for adaptation. And we have multiple actors, we have multiple institutions, we have different kinds of practices, and these kinds of knowledge actors, either KVKs or some civil society organization, is playing a very active role in ensuring that adaptive practices are widely deployed and also are culturally relevant and aligned. So from this kind of a schema, I have some headline statements, five or six, which is emerging from my research. The first is that promotion of local practices is important, but they need to, but and because they are culturally and socially relevant to the region, uh, therefore they also provide some amount of credibility. So, and they also offer an opportunity to look at decentralized institutions. And within those decentralized institutions, inclusion of local actors and players to govern, for example, local resources and govern processes at the local level. So, local knowledge, local institutions have to be preserved and used as an opportunity to promote adaptive practices. Social learning is very important, and some of these uh, intermediaries are playing a very important role in facilitating how we are learning as a society. And therefore, wherever we find collectives being formed, they are playing a very important role in, of course, the proximate goal of creating local employment, but giving a sense of ownership to the community, giving a sense of giving some strength to the community, and recognizing and legitimizing the knowledge that exists between them. Uh, it's important to recognize that there need to be spaces or platforms where integration and of local and modern knowledge happens, and this is this should happen in in the context that social and cultural bases are preserved, traditional structures and institutions are also recognized, and the knowledge transfer and exchange happens by recognizing these realities, and KVKs and local intermediaries are playing very important role in doing this. And of course, collaboration is important, but you need to have that node through collaboration happens. This is a picture from Rajasthan where they are trying to revive local uh, 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 water resources or water sources by using a community as an entry point. And of course, capacity building is very important, particularly to ensure that local stewardship is established, but also we kind of create systems of intergenerational learning. Northeast, and it's very popular that children go and young people go and practice farming. And I think by bringing them closer to nature and looking at making them aware of the uh, the hard work that goes into growing food, for example, is builds a sense of environmental consciousness, and also a sense of respect and dignity for the kind of work a farming community is engaged in. And this is all kind of uh, uh, held by these knowledge intermediaries like KVKs and other civil society organizations. I'll close, and of course, awareness is important, and this was a point linking back to institutional support agenda. So, and I think here also knowledge intermediaries are playing a very important role to kind of navigate power dynamics at the local level, but also and also ensuring that the uh, chance of accessing institutional support is fair and equitably distributed. I'll skip this, but I'll end with two important points. So, as we all know, that cities are increasingly becoming important in within the climate agenda. More so because cities are places or spaces from where much of the greenhouse gas emissions are originating. But I think cities are also places where we see significant challenges on the adaptation side. So while mitigation is happening at a certain pace through a certain governance and policy regime, adaptation is largely a very local phenomenon. And there's a lot of government programming happening to make our cities resilient, our cities productive spaces, and are also and cities as inclusive and dynamic economic hotspots. Uh, but within cities, at this moment in India particularly, we are grappling with three kinds of challenges, and these are broadly categorized as three risks. Development is, so there's poverty, there's vulnerability, social vulnerability, and there's also massive inequalities. There's cities are very informal in nature. 70-80% people are engaged in informal activities. So development risk is an important element. Adaptation, of course, is directly linked to the present agenda. So there are certain kind of shocks and stresses that we are experiencing, and some of which is linked to disasters, because there are certain climate hazards that have a disaster have a disaster linkage. But all of this are essentially so whatever development programming is happening is essentially aimed at reducing risk, and the challenge is that at the local level, within the constraints, within the budgetary constraints and capacity constraints, and the multiple agendas that we are confronted with, we need to be mindful of the fact that there are three simultaneously. We have to reduce risks on three fronts,
May I,
and that too simultaneously.
Dr. Amir Bajaj, may I request you to conclude? We will come back to you for panel discussions.
Yes, I'll stop here only. Yes. So,
Yes.
so I'll just make one headline statement. So, essentially, and this is my personal research, that if we enter from a perspective of vulnerability and look at how we can focus our programming towards vulnerability reduction, more importantly, by looking at how can we improve access to basic services and how can we improve livelihood opportunities and strengthen livelihood opportunities, we would be simultaneously addressing the three risks, and our cities would become increasingly resilient. Thank you very much, and sorry for overshooting a little bit. Thank you.
Yeah, thank you. Thank you so much. Thank you so much for covering really very important aspects, climate adaptation, and prioritize this risk reduction. That issue, of course, I mean, you have covered many other issues, labor issues, and interaction with locals to gain the insight into knowledge, actors, and social learnings. So we will come back to you, sir, for this during panel discussion. Thank you so much. May I now invite Dr. Shyama Sri Dasgupta, Professor Shyama Sri Dasgupta, for a presentation. Please.
Thank you very much. So actually, I'm going to continue probably what Dr. Bajaj has already said, because I'm also going to talk about some of the field experiences that we had from the Jammu and Kashmir region, and that too regarding the agricultural adaptation. So let me share my screen.
Yeah, please.
I hope this is visible.
Yeah, very much.
Okay, so first of all, thank you very much for inviting me to this, very special occasion, and I am, grateful to be a part of this, to be with such august, speakers here. So I'm going to talk about, this is the title of my presentation. I'm going to talk about to cope or to adapt, a case study of the one of the districts, which is Kulgam district in Jammu and Kashmir. So at the very outset, I would like you to, notice that I have used two words. One is coping, and the other is adaptation, and eventually we will discuss what is basically the difference between coping and adaptation, and which one is more sustainable or which one is more practiced by the farmers that we found out in this particular study region. So before I enter into the the experience or the data that we gathered from the field, let me take you briefly through the format or through the the analytical framework that is being used to understand the risk that is arising out of climate change. And this diagram is depicted from IPCC AR6, and the same the kind of the same framework was also there in IPCC AR5. So now we have kind of got the framework within which the climate change risk can be analyzed in a sort of comprehensive manner, I would say. So let us spend few minutes to understand what the diagram says, and specifically this part of the diagram. If you see at the center of this circle, we have the nucleus with like three colors intersecting or interacting with each other. So let's first see what these three things are. If you look at the dark blue part of it, this is called climate hazard. So increase in temperature or flooding or any climate extremes, they are considered to be the part of climate hazard. Now if we look at it from the perspective of human being, then we do not do much with climate hazard through adaptation. I mean, adaptation has nothing to do with climate hazard in a sense. We have to go through the channel of mitigation. Now, if you look at this light blue component here, this is about the exposure. So suppose the climate hazard takes place, suppose there is a flood, but there is no human being or ecosystem, or there is no biodiversity there. So it doesn't really matter. So it depends how many people, how many systems are being affected by the hazards that we are talking about. So that's about the exposure. And the third part, which my research mostly entails of, is the vulnerability component, which is here. If you can follow my cursor, this is here the yellow part of it. So what is vulnerability, and why are we taking it out of climate hazard and exposure? So let me just give you an example. Let's think of the farmers. Now, if the farmers do not have access to institutional credit or institutional insurance schemes or weather advisories, these are inherent vulnerability of the system itself, whether the hazard hits or not. So we try to penetrate from this channel by saying that if you can reduce the current vulnerability that the farming system, or to be more general, any system, if for any system, if the vulnerability can be addressed, if the resilience can be developed to reduce the vulnerability, then automatically the risk of climate change that is happening at the intersection of hazard, exposure, and climate vulnerability, that will be reduced. Of course, the hazard matters. Of course, the exposure matters. But intervention through the channel of vulnerability has a very win-win kind of problem if we are looking at the whole development agenda. But again, to say that doesn't mean we don't have to take care of the climate hazard part. Now, if that is the framework, what we have done as my current research, and we have been collaborating with IIT Guwahati and IIC Bangalore, and what we have been doing so far is to understand what are the vulnerability, what are the drivers of vulnerability at different levels. So we have carried out the studies at the district level, for example, in India, and found out which are the, from the perspective of social, institutional, and biophysical characteristics, which are the most vulnerable states or districts in India. And but I'm not going into the the detailed discussion of that. That's a separate study probably. But I have taken a part of that study, and if you look at this portion, this is the Western Himalayan part. So these are the districts of Western Himalayan part, which has, and we started the initiated the study before Jammu and Kashmir were bifurcated into two union territories. So this shows the erstwhile Jammu and Kashmir, then you have Himachal Pradesh, and we have Uttarakhand. Now, if you look here, the darker red shades, these indicate the districts which are highly vulnerable. Now, when I say highly vulnerable, what kind of indicators with respect to which are they highly vulnerable? So they are typically, as I said, socioeconomic indicators, institutional indicators, or biophysical indicators. So we check, how much forest cover, for example, these districts do have. What are the livelihood options? Are they totally dependent on primary sector, that is mostly agriculture, or are they diversifying from agriculture to horticulture, which gives them some sort of a resilience? Or, for example, we looked at income level, access to farm credit, or what is the access to insurance, and so on. So based on, or connectivity, another very big issue when we talk about the Himalayan region. So this is how we got the the map or the positioning of the highly vulnerable districts, and you can see that they are a large number of them. They are actually concentrated in this part of Jammu and Kashmir. So this is basically the Kashmir Valley that we are talking about. In Uttarakhand also we have some, but now I am going to focus on here. So as I said, this is a part of the larger study, and we took multiple districts. We took, apart from Kulgam as well. But when I was looking at the story of Kulgam, the way it emerged, it's very interesting, and it sort of lets us know why, as along with the national level study, the district the regional studies, it's very important to understand certain case studies. It gives you the nuances about the gaps in adaptation, where the intervention is required, what is going wrong, are they going for any maladaptation practices, and so on. So this kind of micro studies also give a lot of insight, which I am going to share with you. So just to inform you that climatologically, the entire Western Indian Himalayan region it falls in the Indian northwestern agroclimatic zone, and this Kashmir Valley falls into the temperate agroecological zone. So this is the district that we are going to talk about, and this is situated somewhere here. Actually, we'll see that Kulgam is not one of the most vulnerable districts, but it fell in quartile 2. But it had some, interesting characteristics for which we chose this district to be studied. And we actually went to 3 blocks in Kulgam district. One is Kulgam block itself, the next one is Pehlu, and the third one is Devasar block. So why Kulgam district? I mean, why I said that, Kulgam district was a very, interesting case, which actually we thought would be important to be studied. See, if we look at the, the overall scenario in Asia, again, if you look at IPCC AR6 and so on, we see that there is a huge risk that the entire continent is going to face in terms of food and water security. So the moment we talk about food security, agriculture comes to the question. So agriculture is strategically very important from 2 perspectives when we talk about, climate change. One is that those whose livelihoods are dependent on agriculture, they are very highly vulnerable to the changing climatic conditions and the hazards. The other thing is that if agricultural sector is hard hit, then there is going to be an impact on the food security. Now, I'll show you the data later, but in Kulgam district, what we found is that there is a significant transformation from rice cultivation to apple cultivation in one hand, because that is one of the coping mechanisms or adaptation mechanisms that the farmers thought would help them. On the other hand, this particular district, it has high dependence on the public distribution system. So for rice itself, they are dependent on public distribution system. So far, they were getting their home produces to supplement that. However, now because of climate change, they are shifting away from rice and moving to apple cultivation. So it's a two-way challenge that they are facing, and which is going to aggravate in a longer term, which is very difficult for the farmers to assess in a short term. That's one reason. So these are some types of vulnerability that they have. Other thing, if you look at the third point here, actually, the other thing that you can see, if we look at this region, and this is not only specific to Kulgam district, this is probably, the characteristic of the entire hilly terrain in India, that there is no land consolidation. So the farmers, they hold very small pieces of land. Most of the farmers are holding less than 1 hectare. They're marginal farmers, and these lands are not located in one space. So in 3, 4, 5 places, these lands are fragmented. So this gives them a very significant, strong, operational challenge. And because they are marginal landholders, the earning is not totally protected. So they have several challenges in terms of developing the resilience in the agricultural sector. So that is the vulnerability component. If you can recall the diagram that we discussed, this is the yellow part, the vulnerability component, which is going to be there whether the climate change hits or it doesn't hit. On the top of it, what we have major, climate hazards taking place in this region. So here are some of them are, documented, which we have taken from the climate change cell of Jammu and Kashmir. And there are some of them are quite regular, and they are, across the entire district. This is specifically for Kulgam district. One is winter snowfall. Second is snow avalanches and snowstorms. Hailstorm is currently coming up to be a very, important challenge to agriculture, especially for the apple growers as well. Cold wave, that is another, which is increasing. Now, when we spoke with the, the farmers, we talked about their perception, because whether I'm going to adopt some strategies or not, and whether that is going to be a long-term strategy or not, that also depends on whether I perceive that there is a change in the climatic condition or not. So we actually asked the farmers, do you think that there are certain changes in the climatic conditions? Are you, experiencing more number of hazards and so on? So they talked about 3 things which are very important. First of all, they said that, see, the nature of hazard is changing. Earlier, this region, we were, scared of flood. Because of flooding, we started converting from rice to apple cultivation. Now, the challenge that we are facing is severe hailstorm. And these hailstorms are actually destroying the buds of the apple. So you go for one adaptation strategy. However, the nature of the disaster or the nature of the hazard changes, and therefore you find out that this may not be sustainable in a very long term. So this is one challenge, the changing nature of natural hazards. The second one, They say that these hazards are more frequent, and the third thing, they have become more severe in nature. Now, this is what their perception is. I'm not going to make a claim whether that is actually the case or not, because we have not, matched the data. That is the plan, but we haven't done this yet. So you can see that this is a region which faces high level of vulnerability. There are, incidents of climate hazards which are quite frequent as well as severe, and there is a farming population, so the exposure is high. So at the intersection of that, again, if I take you back to this diagram, you see that the risk arising of climate change, that is very high in this particular region. And there are different sources that we have talked about. Quickly, just to talk about the sample, we actually talked with approximately like 230 households, which comprises of approximately 1,300 individuals. Yes, is there a comment? Okay, yeah. So approximately these many individuals, mostly they are apple growers, and gradually they are converting to be apple growers from rice cultivation. Okay. The most important thing that I would like to highlight is this part: farmers type based on the landholding size. If you look at the landholding size, most of them are marginal farmers, less than 1 hectare of land. And what is the average number of land holdings? It's approximately 3. So you imagine there is a farming community mostly holding less than 1 hectare of land per family, and this less than 1 hectare of land is distributed over 3 to 4 places. And therefore it's very difficult to manage. Even if you are going to implement some strategy, this is going to impose a lot of challenge in the implementation part as well. So this is one of the major challenges that is being faced by the farmers in this region. Now the question is that, okay, what the farmers are doing, and here I'm going to focus more on the apple cultivation, because we have seen that most of them are apple growers. The rice cultivators also do have their own challenges, but let's look at this, what the farmers are doing in order to protect their crop from these climatic hazards. So there are 5 to 6 prominent measures that we came across while interviewing. One is adjusting the apple farming practices. So you change the date of harvesting depending on any advisory that you get, or adjust the pruning and training, adjust the plowing practices mostly for the rice cultivation, or spraying practices, so on. So you change the farm calendar, or you change the timing of the practices. That's the first measure that they take. The second one that we have come across, there is a land or crop transformation and apple variety diversification. So they are
Some
trying to,
disturbances. Excuse me.
yes. Okay. So there is,
Yeah,
so there,
some disturbances, voice disturbances are there.
okay.
Yeah.
Is it clear?
Anyway, I mean, it may not be. Yeah. Now it is okay, but it may not be in your control actually. It's maybe some transmission issue. Yeah, you please continue.
Okay. So crop
Yeah, 2
transformation.
more minutes.
Sorry.
You are left with 2 more minutes.
Yes. So they are going for crop transformation,
Yeah,
right?
please go ahead.
Yeah. And they're also investing in the water storage system and so on. So these are the practices. Now the question that we asked, are all these practices sustainable? Are all these practices the same? And the answer is no. See, if we look at all the strategies that the farmers are adopting for, we can clearly see some of them are coping strategies. Now, what are the coping strategies? They are really short-term strategies. You face with a challenge, you try to overcome that challenge in the shorter run. Whereas adaptation is more of a long-term measure. On the other hand, if you look at the agency-wise implementation, there are autonomous measures. Most of them are autonomous measures, which means that the farmers are going for these measures by investing on their own. The contrary to that, what we can have is the planned adaptation measure as well, where you have deliberate policy decisions. Now, in order to, in a scenario when you have, small fragmented landholding, severe water storage, less connectivity, it's very important to have certain planned adaptation policies in place. Of course, the autonomous coping mechanisms, that is going to help, or that is going to supplement these conditions, but this is something which is very important. Now what we have done is that we have identified the typology of the responses. So which one of them are autonomous coping, which of them are autonomous adaptation, and so on. So what we found that most prevalent policies, these percentages show how many, what proportion of households are actually, or the farmers are actually going for this kind of approaches. We'll see that most of the farmers here, for example, adjusting apple farming, they're going for autonomous coping measures, and there is a significant dearth of planned adaptation measures. What are the planned adaptation measures that are not there that we have identified? One is there is very significant dearth of planned water use management. So there are some private initiatives there in order to harvest rainwater and so on. But again, see, because the land holding is fragmented, it's difficult to transport water from one place to another place. The second one, which is very, very crucial, we did not find a single farmer who had access to crop insurance, especially weather-based crop insurance. That was not there. There was lack of dissemination of early warning system. Now, this is also due to connectivity. It's not really government's fault, but it's a system that's how it's operating. The fourth one that was not there, planned agroforestry. Now, when I say, that it's very important to have a planned adaptation strategy, what do I want to mean here? If you look here, this particular diagram, this is from the field site itself. If you see here, this is how hailstorms have destroyed the buds of the apples. Now, in the neighboring state, in Himachal Pradesh, now they have started using this, hailstorm proofing nets. Now, this needs to be, now these people, they don't have any information about it. We asked them, have you heard of this? They haven't heard of this. Now, information, because of this connectivity, the information also passes in a very slow manner. So that is where the institutional adaptation has to come in place in order to make them understand what kind of policies are very important. Second one, and this is where I'm going to stop with. See, this is the weather advisory. This is the document from 2021, and this is late October, which is actually the end of harvesting season for apples. Now, the weather advisory was released on 20th. It reached the farmers on 21st, and it says that the rain is going to be there from 22nd.
Slide.
Sorry,
You need to move the slide.
I am moving. Can you see it now?
You need to.
I'm moving the slides.
Ma'am, your slide is visible. I think it's the issue with the Millinsers network. Ma'am, carry on. It's visible to us.
Okay. Thank you. Yeah. So see, it's an advisory which is being passed on 20th. It reaches the farmers on 21st, and they have to take an action by 22nd if they have to do something. Now, suppose, I mean, this is good enough because this is the end of the harvesting season. Had it been in the beginning of the harvesting season, they have harvested the entire, all the apples that they have, and this is the fate of the apple that you see there, because it can't be transported. So there's a lot of multiple layers of challenges are there. So we say that, for example, we can make a very simplistic statement. There has to be weather advisory. So when we ask the farmers, do you have access to weather advisories, they would say yes. But how is it functioning? These are the problems that you have. So that is why I picked up this case study to demonstrate that even if certain systems are in place, it's very important to understand the micro studies to decipher what are the challenges, where are the barriers, and where do we need to intervene. So for example, here we recommended a couple of very simple things. Can we have institutional water harvesting system in place? Can there be some training to the farmers? Can there be some centralized mechanism for that? Can there be cold storages? Although I know cold storages are highly debated, but can there be some mechanism by which the harvest can be stored? Can the nets be distributed? Of course the farmers are going to buy it, but can that be done? And that requires the institutional centralized arrangement along with farmers own behavior. So I'm going to stop here. I just want to there are some references if someone is interested. I'm going to acknowledge the work of some of my students who were there with the field with me and did a lot of interview and data analysis as well. So the final statement and that I'm going to make, that we discussed about the social norms and the social the understanding of social norms and social learning. Now it becomes a little bit of challenge in case of the hilly terrain because the households are sparsely populated. I mean, one is here and the other is there. So probably in those kind of cases,
Yeah.
it's very important.
We will come back to you, madam,
Yeah.
during panel discussion.
Yes, yes. So I'm just going to stop here. That's the end of my presentation. Thank you very much.
Please, 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 please. Thank you. Thank you so much. Thank you so much. Thank you. Thank you so much. Thank you so much for elaborating on this coping and adaptation analysis, particularly the climate change risk and what you described through this IPCC AR6 Working Group 2 assessment, particularly the vulnerability analysis. What you brought out is really important. Hazard and vulnerability analysis, what you showed a case study, Kulgam district, that is really important. And the main thing is the policy, the social learning, what you discussed about this, the impact of changing natural hazard, and then the planned adoption policy. So thank you so much. We will come back to you during this panel discussion. Now, may I request Professor Dr. Bhaskar Sinha, IIFM Bhopal, to present. Please, Professor Bhaskar Sinha, please.
Yeah, thank you so much. Can you hear me?
Yeah, yeah.
Okay.
Yes.
Okay, let me also try putting one slide here.
Yeah.
Okay. So can you see this?
Yeah, it is appearing. Maybe some delay in
This is
my
fine,
side.
fine, fine. Go to
Okay.
PPT mode.
Then please go ahead. Please go ahead.
Yeah. Okay. See, thank you so much once again for inviting me to this series of talk on very important issues related to climate change and other things.
Go to presentation mode.
Yeah.
Yeah, can you see now?
Yes, thank you.
Okay, good. Thank you.
Yeah.
Now,
Yeah.
see, I'm sorry that I joined late, so I missed a couple of very important presentations which this session deliberated. And the delay was unavoidable because I was traveling. I just came rushing from Delhi. Okay, I didn't want to miss this occasion. Now, there are two ways of, since I have been given 20
Great.
minutes time.
Thank you.
So if I go in PowerPoint mode, and then it would be a little difficult, though I have made my presentation. Or if you want, I can go, without PowerPoint. Let me try. First, let me give you the concept what I'm going to speak on. We are all talking of adaptation and mitigation. I don't want to spend a single minute on talking what is adaptation, what is mitigation. I've done a couple of projects. I think the 4 projects which I did with Ministry of Rural Development, GIZ, UNDP. This was to look at the adaptation potential of one of the largest program in the world in the name of MG Narega. So I would like to spend some time on that. And if time permits, I would also like to spend on that if you are talking of rural adaptation, that is enhancing the rural livelihood, then tree outside forest also is a very important component in terms of enhancing the income of the farmers. Okay, so there are 2 aspects for rural adaptation. One through the India's largest rural development program, that is MG Narega, and other through the tree outside forest potential. Now, if you look at the goals of MG Narega, it says strong safety net for the most vulnerable people. It addresses, this is talking of the empowerment based on the right. Okay, and if you look at that adaptation and the impact of climate change, we all know that climate change is going to hit hardest and earliest to the poorest of the poor of the developing country. In case of India, the rural community or the marginal farmers. So if you were to prioritize adaptation measures, I think these are the communities which should be prioritized. Now, if you look at the goal of MG Narega, it also says that it will provide 100 days of guaranteed employment for and skilled work, provided you are willing to work. So this both matches each other. Matches, I mean, the objective, if you look at the objective and target, I mean, it is the same. Now, we were given this task to broadly evaluate what is going on in Madhya Pradesh. Okay. So let me not get into the details of how we all did the studies, but if anyone has any questions, I would love to answer. Okay. So what we did that we tried and understand first that is Narega making any impact on rural development? A. B. Is there any potential of enhancing the adaptation mitigation of climate change through MG Narega? So the first thing was to see what is that impact which MG Narega has done. And therefore, we selected 4 districts in Madhya Pradesh, 2 representing the rich natural capital, 2 poor natural capital. The reason why we took this and divided this district because Narega again is MD Narega is again demand driven. So we were expecting that if a district is poor in natural resources, the variety of work which will be demanded by the people will be different from the kind of work which are demanded by the people in districts which has poor natural resources. And then subsequently we took blocks and Gram Panchayat. And Gram Panchayat and blocks, criteria for selection of block was the highest and lowest allocation of fund and involvement of other line departments so that we could see the diversity of the work and also where the majority of the works has taken place so that we could actually make some assessment and some impact. Now, if you look at, we all know that broadly, these are the 4 things which for sure from all literature, climate change impacting. That is the food security, water, health, ecosystem, extreme weather events. Now, how does the activities which are permissible under MG Narega try and address to each of these impacts of the climate change? So if you look at that water scarcity, which is the biggest problem, not only for the country, but also across the globe, and you'll find that under this MG Narega schemes, there are so much of schemes related to water regenerations, creation of water bodies. Kapil Dhara is not, I mean, something which is, I mean, individual wells given to the farmers. You have ponds, you have Nirmal Nir. Nirmal Nir is the community wells, and there's a lot of plantation and watershed. So if you look at that impact, we are talking of adaptation. Adaptation is a planned activities to meet the challenges of climate change. So water is a problem. Water is going to be further scarce. Okay. And if you have these programs in terms of providing wells, in terms of providing ponds, in terms of doing watershed and plantation, it is definitely contributing to improvement of the water for the farmers. And therefore, I mean, there is improvement in irrigation, there is improvement in potable water, there is improvement for cattle, improvement in agriculture productivity, and this will also lead to reduced water contamination diseases and overall improvement of the water regime. Similarly, if you look at, I mean, on the food security, all these waters, and there are also activities like farm bonding and all, again, this is leading directly to increased yield, increase in crop diversity, increase in soil moisture, a lot of groundwater recharge. Okay. And then improving ecosystems for functions and services, that is afforestation, rehabilitations. So you'll find that it is also contributing towards enhancing the ecological resilience of a particular area or a block or a district or a village or a landscape. Okay. Now, similarly, in terms for the, I mean, it will also provide relief for the, I mean, fighting with the extreme weather events. Now, and these are the if you look at and see what are the activities which has been done expenditure towards, I mean, different extreme weather events, ecological sustainability, water scarcity, because we categorize in this, all those activities, we have categorized in this form, and we try and see that how these are done and implemented in different states. Now, if you look at that impact, now the impact is very significant. If you are talking quantum, I mean, you look at, I mean, it is differing from something like from 20 to, 45%, which is contributing, which is showing increase in the water irrigations, and which is a direct implications of increased crop yield and productivity. You'll find that wheat production has increased, ratio, I mean, if you look at that economy has improved. Okay. So there is almost significant increase of the income by something like 6,000, which is significant. Now, the other issues, what happens that since it is a demand driven work, so there was a lot of demand for creation of individual wells. So what it led that in many of the Gram Panchayats, I mean, there was so much of wells, almost 60, 70 wells, but there were no recharge. So what will happen that if you are only allowing wells to come up, and if you are not undertaking those activities which are responsible for improving the soil moisture and the groundwaters, then you will end up having only wells without water. So therefore, we also did, and then we did mid corrections and suggested the government that wherever there is wells, wherever, I mean, if you are issuing a wells, you should maintain a distance, and you should also put a prerequisite that if you have to have this much of well, you have to have watershed activities, you have to have plantation, you have to have farm building, you have to effective recharge speed, so that the viability and sustainability of the well or the assets created is also maintained. Otherwise, I mean, probably in long terms, it will become meaningless. There's so much of a small sea, which you'll see that how it has impacted the individual farmers. Okay, there's a lot of activities which related to the forest department, how this NREGA has given them leverage in terms of taking up plantations and watershed and scientific forest management, which otherwise they were not able to do so, because I mean it provides you huge, I mean, money for engaging people in providing employment. And majority of the forest activities, almost 90% of the forest activities are related to, I mean, creating wage employment or daily wage employment. It doesn't require heavy machineries and other things. So it suits the NREGA objective also, and it suits, I mean, departments also in terms of doing project, synergizing their activities, leveraging from the NREGA fund. And there is so much of successful case studies, I mean, from different parts of the Madhya Pradesh. And so what are the, how does the policy comes in? Like, let's say, I mean, if you were to say that we are saying that country like India, I mean, we are trying to improve the forest cover, one forest department is doing. Whereas if you look at, I mean, district like Chhindwara and Panna, you will find that there are two ways of measuring forest or improvement in forest. One is the actual forest cover, which is being reported by the government of India every 2 years, that you are saying that 22% of India's geographical area is under forest cover. Okay. So forest cover is all those land which has more than 1 hectares and which has a canopy density of 10% will classify as forest, irrespective of whether that land belongs to a farmer or the government. So if you look at a notified forest area, that means notified forest areas are those areas which are recorded as forest and which are maintained by the government. So if government were to prioritize districts across the country, then in that case, if you want us to see what is the recorded forest area, that is notified forest area, and what is the actual forest area, and if there is a deficiency between the notified forest area and actual forest area, so those districts can be given target that look, this is the target which you have, because you have area under, I mean, as notified as forest, whereas the forest cover is not present, and therefore take this fund, leverage this fund, and do afforestation, soil moistures, and watershed activities, irrespective of whether you get a fund from the department or not. So these are the very powerful, I mean, instrument or policies interventions which has done wonders, especially in terms of improving the rural infrastructure of the people, in terms of creating employment, in terms of creating water bodies, in terms of improving the water regime, in terms of improving the ecological regime, in terms of improving the green covers and associated benefits. And so, I mean, if we talk in terms of the vulnerability, I mean, we also did vulnerability, I mean, based on the indicator-based index, and we have published quite a lot of papers. If you're interested, I'll share a few of the papers which came out from these projects. So you'll find that, I mean, these are the almost this NREGA alone, MG NREGA alone, were able to reduce the vulnerability ranging from 14% to something like 54%, which is very significant. So the issue is that if this particular program, which was not aimed for adaptation and mitigation, the prime objective of this particular program was to provide employment by creating assets. So if we could create assets and provide employment, okay, and if we are trying to look at trying to improve the ecological efficiency or trying to improve the way it is being implemented, in that case, the adaptation and mitigation component, which could be achieved through MGNREGA, and also the asset sustainability is enormous. And then thereafter, after this, we also did a studies in terms of how all these activities which are being administered or which are being implemented through MGNREGA could be further extended in lieu of climate change adaptation mitigations by following following improved techniques and planning, whatever it is being planned, by the communities for implementation in their villages and so. So what I'm saying that it's a huge potential. It has already contributed significantly in terms of rural infrastructures. There's far more potential in terms of creating. It has far more potential if these are well planned. It could do further wonders, and I think this is one opportunity which addresses vulnerability from many different perspectives, not only by providing direct income, but also by providing, assets by which they can improve their livelihood for a longer period of time. So there's just one, the other which I wanted to discuss a bit about, we are all talking of income generation of the farmer. Okay, so can I take another 5 minutes? I have 5 minutes, sir.
Sir, already the time is over, sir. You may
Over.
take 2 minutes, sir.
Okay.
We have to again go for the discussion.
Okay, sorry.
Please.
Okay, I'll just 2 minutes. I'll just summarize. So we are saying that tree outside forest, again, which is something which can do wonders for the farmers, and not only in terms of improving the income, but also strengthening the ecological base. And therefore, you will see that, in 2014, Government of India also came with a policies called National Agroforestry Policies, which is exclusively dealing with the challenges and opportunities of growing trees by the farmers. The question is, why farmers are not growing trees, even knowing fully well that it can provide them additional guaranteed income. It's not that you need to tell them. It's not that we don't know. So there are policy issues. We need to address that. We did a series of studies, and we also published 3-4 papers on that, which was taken very seriously by the government also. And there are a lot of committee meeting and other things, but something that is beyond that, I can't tell anything. But what the point which I'm pitching here, that we should know why people or the farmers are not growing trees in their own land despite tree having a huge economic benefit to them. And if you look at and if you analyze, we did analyze 3-4 districts of Gujarat and Madhya Pradesh. And one of the reasons is that the way the trees are governed for felling, for transitioning in India is something which is very cumbersome. And that is one reason which is not allowing farmers to grow or adopt growing more trees. So there is need to relax of the policies with respect to the felling permit, with respect to the transit permit, and also with respect to creating the supply chain link. If you look at a country like India, we are a net importer of paper and pulp by 60%. If you look at the timber productions, it is going down. And if you look at that import of timber, it has increased by 7 times in 20 years. And we are boasting that we are having 1/4 of the land under forest cover. So we need to ask, if we are managing forest, we are not protecting forest, we are managing forest. We are managing forest for what? Whether timber, water, biodiversity, whatever you say it. Okay. Or for income. But in that case, the forest should be well monitored, well reported, also on those parameters. That yes, we have managed this much of forest, this has led to this much increase in the biodiversity. And if you are saying that you are doing restoration, then we should be also reporting that this was the degraded land, and this is how much we have converted or we have restored. If we are talking of improving the improving the tree stock productivity is purely from the plantation, then we should say that these are the plantation which are managed purely for the productivity purpose, and this is how we have done. So there are policies issues which we have also recommended, and we have very strongly advocated for this. I can't say that everything has changed, but slowly.
May I request you, Professor Sinha?
Okay.
Yeah.
So
May I request you to conclude, sir?
I'll stop here only. So by saying that whatever the existing resources, laws, policies, tools which we have, we need to see from climate change point of view, not that it is not doing anything. People are doing a lot of people are doing a lot of things. We need to see and optimize the potential of such resources and policies. With this, I'll thank you and I'll take any questions if you have any. Thank you so much.
Yeah, thank you. Yeah. We'll come back to you, sir. Yes, sir. Thank you, sir. Thank you so much for elaborating the enhancing rural adaptation, Manarega and TOFs. Particularly the this linkages between Manrega and climate change, an impact of Manrega in climate change adaptation and mitigation. That is really very interesting. We'll come back to you, sir. So now we'll switch over to the panel discussion, sir. So it is good that Miss Suruchi Bhadwal also there, and we'll start with that. But before we start the panel discussion, quickly let me just share our climate change book. Just so just I want to flash this book. Actually, this is open access book, and I think you may be able to see this book, and this may be interesting for this for knowing the signs of climate change. Just I wanted to flash this book. This is available online and open access book. Yeah. Now we'll switch over to this panel discussion. May I request Ms. Suruchi Bhadwal, Director Earth Science and Climate Change Theory. May I ask these questions which are posed here? Can climate smart agriculture CSA be considered as a key strategy for climate change adaptation and mitigation? What key issues of climate change can this address? Bhadwal madam, please. Are you able to listen, Bhadwal madam?
Yes, sir, I can hear you. Can you hear me?
Yeah.
Thank
Please,
you.
please.
Thank you very
get
much.
the question, madam?
Yes, sir, I could get your question. Thank you very much for the opportunity. I will get on to the agricultural section, the question in a minute. Just by summarizing, what we heard all the speakers say in the previous session, of course, linking it to the IPCC AR6 context, where the report that was published this year very clearly highlights the impacts of climate change that are already being observed in many ecosystems, including human systems like the agricultural sector. And these sectors are basically, systems are basically affected by various reasons. One is the gradual increases in the climate that are being observed, but also the frequent and intense nature of extreme events that we are observing in the form of droughts and floods and flash floods and cyclonic storms and storm surges in coastal regions. So this is basically just synthesizing that impacts are likely to be felt widespread across all sectors. And there is what worldwide it is being realized is that there is a threat to food and water security, and of course a threat to the efforts to meet the sustainable development goals. The impacts in India is likely to be unevenly distributed. We know that India is going to be far more hotter and wetter in many parts, but with a skewed distribution of rainfall, basically these impacts may be very varied. The agriculture sector is to be affected. Water resources and health are also likely to be primary areas of concern. Now, with regards to India needs to strengthen its NDCs that have been submitted with regard to the adaptation to climate change. And coming on to your section on the agricultural sector, the impacts are well known. Most crops are affected. We lie in the tropical area. Our crops are already grown at a higher temperature threshold. So any further increases in temperatures may further impact the productivity of these crops that are grown in the subcontinent. We have already started observing losses in forms of fall in production in various crops. For example, there are instances of how horticultural crops have been affected and perishable, food has been affected, leading to losses worth 3,500 crores in the horticultural industry a couple of years back when apple was affected in the hill states. There are also impacts of extreme weather, snowfall, and temperature changes that we see on production of crops. This further has links to food availability and food security issues and livelihood sustenance issues, and of course links to job security and the fact that it creates social inequities and further starkens the gap between poverty. Therefore, agriculture is sensitive, and we need to look at interventions or measures that can help reduce the said losses from the agricultural sector. And one of the ways that we're talking about to do that is to promote climate resilient agricultural practices and measures by way of focusing on technological, socioeconomic changes, policies, and practices which can help support this. Now, what are climate resilient agricultural practices or climate smart agriculture that we're talking about? Basically entails a range of technologies and applications that can be considered. This includes at the crop level, thinking about technologies that like biotechnology based applications, looking at new variants and varieties that can be produced and introduced that are heat and saline tolerant, that can basically survive under waterlogged conditions during floods for a period of few days. Strengthening of farmer producer companies for provision of quality and certified seed quality testing facilities to be set up, skilling of these organizations and human resources within them to be able to provide the quality and certified seeds that are needed to have a good productivity. Focusing on soil quality, where the use of organic manure, traditional means and methods being employed. Role of new technologies include looking at microbial technology to enhance soil fertility, nanotechnologies for nanofertilizer applications and nanopesticides, and promotion of biopesticides. On the technology side, basically looking at technology-based application of inputs, including farm inputs, including manure, irrigation, which are largely sensor-based systems being suggested, and land salinity management measures. Use of efficient irrigation systems. We do know, we all talk about drip and sprinkler-based systems that can be used, but also looking at watershed plans and water catchment treatments, drainage line treatments, water storage, construction of harvesting systems, micro irrigation propagation, and protective irrigation systems that can be promoted. In certain cases, we are also looking at the possibilities depending on the crop and the terrain at which they are being grown, looking at protective farming through the use of shade nets and poly houses. But of course, this has to be very specific to the kind of crops that, are being grown by farmers. Changes in farm practices, including integrated farming practices, a mix of livestock, sericulture, apiculture, poultry, and fishery-based livelihood systems, and looking at mixed farming and rotational cropping systems, which may help enhance soil fertility and diversify the crop base and reduce the said losses from the land. Promotion of other measures like agroforestry and generation of market mechanism for carbon credits. So linking all this up in terms of making agriculture more robust and resilient to both the mitigation and adaptation to climate change, and of course not to leave behind the operation and maintenance of many of the above activities or measures that have been basically mentioned, including the desiltation of reservoirs that are needed for irrigation. Post-harvest management and value chain measures also need to be, focused on, where basically the discussion is largely surrounding the need for enhancing storage, cold storage for perishables, strengthening of value chains to improve supply chain performance and ensure climate resilient commodity production. And of course, the last part of it is with regard to institutional setups to do all this. Basically, we need startups and innovation centers. We need strengthening of research and development. We need to create platforms for sharing of these technologies and scaling up. And of course, the NICRA example, which is the Government of India, successful implementation, which is a national, Institute for Climate Resilient Agriculture that was set up under the CSIR initiative, basically had set up these custom hiring centers at the panchayat level, which is basically providing, tools to farmers, at the local level to basically be able to use it for enhancing his farm production. So tilling tools and other technologies which are accessible to the farmers and available to the farmers through the custom hiring centers, which may help the farmers in terms of coping with the situation. Setting up of seed hub infrastructure, seed banks and gene banks, setting up of information knowledge centers that act as a platform, and build capacities, and training for stakeholders, including farmers and the agricultural industry. I think these are some of the measures that we need to look at. Of course, agriculture is closely linked to water, so focusing on water security, storage and recharge is an element that also needs to be considered while we're addressing the agricultural sector. And with that, I would just leave there. But the last point I would just like to say, while we set up all these measures and we talk about the implementation of these technologies, we do need a robust monitoring and evaluation system on the progress of the implementation of these measures that we are talking about with regard to the implementation of adaptation. And ideally, that would basically help us understand the path that we are following, how much have we been able to achieve, what are the barriers, the drawbacks, or the failures that we entail while we are implementing these measures, and what can we further do basically to improve on the situation. And with that, I would just close my remarks. Thank you, sir.
Thank you. Thank you so much. Thank you. We have noted down your remarks, and we'll definitely report it, make a consolidated report. Thank you so much for your extensive this response. So next I would like to now move to Professor S.N. Patil, expertise in applied geology. What in your opinion is the primary role of climate change in India's water insecurity, and how may it be reduced through policies and governance?
Okay, good morning, sir. Thanks to all organizers for providing this platform. Regarding my opinion about these questions, in my opinion, improving water security is essential in India's development. With the total water demand of India is expected to rise by over 70% by 2025, a huge demand supply gap is expected in coming years. This will act as a potentially significant constraint on economic growth. Whereas industrialization and urbanization and population growth coupled with inefficiencies in water use lead to the groundwater depletion and declining quality of surface water. Climate change exaggerates these pressures. Whereas to implement the policy-based principles of integrated water management, better coordination between different governmental entities should be sought, and industrial and legal framework should be reviewed to facilitate the implementation of adaptation measures. Climate change will be felt by all stakeholders involved in the water management processes, including users. This is an important to implement the efficient water use programs in regions where water availability is likely to decrease. A large investment might be required to ensure adequate supplies, either by building new storage reservoirs or by using alternative water sources. Reduction in the water use can delay or even eliminate the need of additional infrastructure. One of the quickest way to increase the availability is through minimizing the water losses in urban networks and irrigation systems. Along with this decrease in the water availability, desalination and more different approaches for coping with wastewater. Better administration for water resources can help to tackle the challenges occurred due to the climate changes. Put in place clear incentive structures and improve the efficiency of water use. This includes removing preservative incentives, improving allocation arrangements, and considering appropriate water charges. Finally, I believe that to comfort with the additional stress induced by the climate change, public participation in water planning will be necessary, particularly in regard to changing views of values of water and importance of the role that water use will be play in the future and contribution the society is willing to make to the mitigation of water related impacts. Thank you, sir.
Thank you so much, sir. Thank you for your very valuable response. Now, may I move to Professor Kalachand Sen, sir, Director, Wadia Institute of Himalayan Geology, Dehradun. Sir, may I ask you this? According to you, what are the limitations any scientist have monitoring and conducting assessment of climate change in India? Do these limitations create any challenges in developing India's national adaptation plan? If so, how? Professor Sen.
Yeah, thank you, Dr. Mujumdar. Actually, when we understand issues related to climate change and being a geoscientist, I will cover some aspects related to geohazards in Himalaya. That direct impact, if we look into, that is imminent from the excessive events, rainfall, and its impact to the landslides and glacial lake hazards. So we understand that definitely the climate has made an impact to the glaciers, glacial lakes, as well as landslide phenomena. And every year we have observed the intensity and frequency of these phenomena are increasing. In recent last 2 years, there are a lot of landslides in Himachal Pradesh and Uttarakhand. Problem is coming, these are all natural phenomena. We can't stop them, but towards the mitigation, whatever, particularly with reference to the hello, I'm audible, no? Yeah.
Yes, yes.
With reference to the glaciers and glacial lakes, these are all high altitude phenomena, and we don't have direct access to those regions. We don't have accessibility to the regions. We have some period in the year get access to visit those places. So we are heavily dependent on the satellite data and resolution of the satellite data. This is one of the limitations to understand the phenomena, what is going on,
Yes.
and to predict and to warn. But we need to develop some sort of land-based network having a different sets of data sets. All the data have to be through VSAT transmitted to a decentralized processing and analysis system, and where based on artificial intelligence, machine learning will be able to understand the processes 24/7. And whenever we find some sort of threshold, this is the only way we can give some sort of mitigation, because this natural phenomena cannot be stopped, or we cannot stop the melting of the glaciers, we cannot stop the area expansion of the lakes, but their impact to the society, impact to the structures, properties, anything in the downstream can be mitigated by looking into these several sets. So our problem in the adaptation, our problem into the coping up with that still we are not able to get the right type of data, and that is one of the bottleneck to go ahead in that direction. Still we are trying to do and achieve something in that directions.
Thank you. Thank you so much, sir, to bringing out the limitations and the challenges. Yes, we need to have a good data set. Thank you so much, sir. We have noted that you are all concerned, and then we will report it, sir. Thank you so much, sir. May I now move to Dr. Amir Bazaz, Associate Dean, School of Environmental and Sustainability, IIHS, Indian Institute of Human Settlement. Does the development, sir, may I ask you the question, does the development of sector-specific adaptive strategies, especially for industries and economically important business and assets, diverse the focus of policies from more general goals of social equity and urban sustainability? How can this gray area between social and economical sustainability be addressed in the context of climate change? Dr. Amir Bazas.
Uh, Thank you, Milanji, for this question, and I'll be very brief. Mm,
Yeah.
I think there are two or three things that I'd like to highlight here. One is that if you look at the global assessments right from the time when the special report on 1.5 was published, we have entered into an era where the desirable climate action to limit global temperature rise to 1.5 uh, requires massive transformation. Now, transformation of all kinds of systems. Now, this transformation schema has been highlighted, which is being repeated in the AR6 assessment reports also, is that we are now examining this or operationalizing the transformation agenda through system transitions. And there are 4 or 5 system transitions that have been recognized. Industrial system, urban and infrastructure system, they are all systems, and within which there are multiple options that have to be simultaneously implemented. So, uh, so that is one fact. We have entered into this fact. Now, if you look at SPM of the Working Group 2 report, there is a figure, I think figure 5, if I remember correctly, where they have extensively looked at the linkages between the system transitions and the options and the risks these system transitions are addressing, clearly looked at these linkages with development. So, both the reports, Working Group 2 and 3, have clearly articulated that it is not now if you carefully look at the policies, you can achieve system transition, but you can implement desirable climate action on the ground. But at the same time, you can achieve transformation as well as development. So those linkages are established. I think from a policy point of view, it is understandable that development programming is the entry point. And if you look at the SDGs, we have goals SDG 1 to 16, which give us very clear development entry points, and through which we can achieve the transformation that I am referring to. So I think these linkages have been clearly established. It's a matter of creating a transparent rule-based framework, an accountable system, ensure that your monitoring and evaluation frameworks on the ground are good, and and we are able to navigate through the access challenges. So that's point number one. Point number two, I think the larger issue is that I think considering the scale of challenges that the country is confronted with, both on poverty, on food accessibility, on employment, whatever we think or whatever we think about in terms of plans and actions, they have to have a very clear linkage with economic development. So which means that how does a particular action help us revitalize or vitalize economic development? Because the resources that flow out of uh, um, a very good strategy around economic development helps us address the massive development challenges that we have confronted. And on that perspective, we have to have a very clear idea of how a particular intervention, which is say around urban infrastructure or around industrial development, comes back and helps us in delivering on development or development related challenges. That's point number 2. And the linked point to this is that amidst all of this, we have to also ensure that our financial system is stable and our macroeconomic system is stable. So all of these, the climate through its various ways and complex terrains impacts households, it impacts communities, it impacts people, and it impacts businesses, and all of it comes back into the financial system, into macroeconomic stability.
Exactly.
So,
Yes.
so the classic example is the current debate around inflation. So we have to be mindful that whatever interventions we plan, it should not aggravate situations around financial system stability, and also ensure that there is largely a sense of macroeconomic stability. And all of us know what is happening in Sri Lanka. Uh, Poorly implemented policies without regard to managing the macroeconomic risk and ensuring that the macroeconomic risks are managed, you end up in a situation like this. Fortunately, in India, we have that capacity and foresightedness that we will never be in that situation. But we have to be careful. So it is not like someone tells us that some action is possible and it should be done. We have to look from our perspectives. The Prime Minister's uh, uh, call on Atmanirbhar Bharat is about that. We have to put our concerns upfront and ensure that the country benefits from whatever we choose to do. I'll stop here. Thank you.
Thank you. Thank you so much. Very valuable response. We will definitely get back to you, sir. Now, may I request Professor Dr. Nabeen Sarma, expertise in conventional and non-conventional energy system from Tezpur University. Sir, how can photovoltaics be used when it comes to climate change mitigation and adaptation? Can the use of photovoltaic energy as a renewable resource of energy be a component of for national adaptation plan in India? Sir.
So you're muted, sir.
Ha.
Sorry. Thank you very much, sir, for providing me this platform to listen to some great minds and great thoughts, and to put my comments as well. First of all, photovoltaics is already in place. It's Indian government or Indian context of climate change adaptation. It has already got a significant importance. And in the Indian context, by the National Solar Mission, we are already have an ambitious target of 100 gigawatt from the photovoltaics for power generation. That's nothing but to mitigate the climate change by replacing the use of fossil fuel by photovoltaics. The technological advantage is the photovoltaics has become much more cheaper. So now people are coming up with interest to install photovoltaic modules more on a commercial basis as well. So definitely, yes, there is a chance. And even if there are challenges that photovoltaics is not reliable, dependent on the weather, it may not get the night time, you cannot get any energy from it, but it can substantially reduce the load of the fossil fuel and dependence on the other renewable energy sources as well. So this is going to play a vital role in case of climate change adaptation policies as well. Now the challenge is we are, even in the solar National Solar Mission, we are talking in terms of install capacity, that how much we are installing. But I think what the point we are missing is in terms of our energy generation, that how much energy we are generating. The vital difference is we have have installed something, but it is not working, or because of the poor or lack of maintenance, if we are not generating energy, though we have the install capacity or the power, that's not going to make much difference. And the point is raised because of the experience that we can see that whatever the installation of the photovoltaic, most of the times it does not give the desired energy output because of the dust, because of soiling, because of lack of maintenance, or because of the seamless integration with the grid. So hopefully I'm not talking too much technical. But another aspect is about the inspiration for the people to accept or to install the photovoltaic module is also the feed-in tariff or the incentives.
Yes.
So the feed-in tariff has to be very much dynamic, and it has to be in a proper way that in this period, when we have an ambitious target of installation of 100 gigawatt, we increase temporarily maybe the feed-in tariff, and gradually decrease it in a dynamic manner so that our whatever the ambition that get fulfilled as well, people get benefit, and we also put a strong mitigation approach to the climate change. So, we have to, in the policy side, the government of India should think as well that how that can be done with a better or a lucrative feed-in tariff for the people. Another aspect is the grid need to be developed, or grid need to be upgraded, so that the energy generation from the very, very small households can be taken in by the grid. So they have to accept. There is a lot of bureaucratic approach, a lot of technical issues that may come when a public approach that I want to install PV modules on households.
Yes.
Not even a technical person like us, have brave enough to do that because of a lot of formalities, a lot of technicalities, how to handle these and that issues. So we have to make it simple. The grid has to be upgraded and developed so that any small bits of power generation can be brought into the grid, and that can be supplied to where it required at the moment. Another aspect is the electrical vehicle that is coming up in a big way, and that is one of the, I think, major approach to the climate change mitigation or adaptation. But the energy, the battery charging has to be done from the renewable energy sources. Otherwise, the whole purpose is going to be lost somewhere, and we'll be just driving electric vehicles and producing the same amount of greenhouse gases, not in the spot, but maybe somewhere else. So that policy, government is already probably thinking, and it's on the way, but we have to make sure, and there is strong policy so that it cannot be taken from the grid, which is generated from the power sources, fossil fuel based. Another aspect I would like to conclude with this, that engagement of the private parties from the generation to the distribution, so that as a consumer, I can choose the distributor, the company from where I'm going to purchase my power based on their cleanliness, based on their contribution in producing power from the clean sources. So I should have that choice that I want to buy it from the state electricity PDCL or maybe some other private parties, depending on how clean they are in terms of the generation. So it is high time that the private parties should be allowed to from the generation to the distribution up to the consumer level, where people can choose on that aspect, and probably that will help. That is just my opinion and experience in the UK, that we used to choose, or from the purchase of the electricity, that I want to buy it from the Scottish Electric or from the other sources, considering what is the percentage of power they are generating, energy generating from the renewable sources. Okay, I conclude here.
Thank you so much. You have elaborated this issue very in detail, and you have also answered the second question actually about the policies, what the government should implement, what policies for photovoltaic system. So thank you so much, sir. So now next question will move to Dr. Shyamasri Dasgupta, expertise in energy and environmental economics. May I request you to be very brief? We have exceeded the time actually, but we want to cover all the panelists. So do you think finance is one of the biggest weak link when it comes to implementation of climate adaptive practices and development of a national adaptation plan in India? If so, why? How can this condition be improved for India? Yeah, Dr. Dasgupta.
So I'm going to be very brief. In one word, the answer is yes. Finance is a big challenge, and it has been debated everywhere in the Paris Accord, in IPCC reports. Everywhere it has been said that whatever money has been allocated for climate change adaptation, be it domestic funds, be it internationally acquired funds, it's not going to be sufficient. One reason I see, which I, again would like to connect to what Dr. Bajaj has, pointed out, we can't see climate change as a separate issue or separate agenda. This is an overarching development agenda, and all the development sectors are going to be challenged by the effects of climate change. So therefore, in every sector, in every development sector, whatever interventions are being made, we need to understand how they are interlinked with the climate. So that is one way. And, Professor Sinha has made this excellent presentation on how Manrega is also a mechanism, not only for mitigation, but also for adaptation. It's giving additional days of livelihood to farmers who are suffering from climate hazards. So this kind of cushioning, so all these things should be integrated in the financing system. And one point I wanted to make, that why this is, the finance is less. That is a major question. The reason is that there are three things we have to take into account. Again, I'm drawing it from the background of IPCC AR6. What is the co-benefit of any adaptation policy that we take? What are the developmental co-benefits? For example, Manrega, as we introduce the the climate resilient part to it, it increases the livelihood securities, right? So that is what is the co-benefit. Second is that if we do not invest, what is the risk?
Yes.
And if we talk about risk, some things are going to happen which are irreversible, where the risk is going to be infinite. So this irreversibility component has to be there when we decide how much is going to be financed and what is the cost of adaptation. So the trade-off between these three, that really needs to be understood very clearly. And I think it is high time for the entire world to look at how the national budget is going to be allocated in different expenditure heads. I won't elaborate on that, but we can see where we are spending a lot of money, not only India, the entire world. Let's forget about that. We have a bigger enemy to fight with. So more funds should go there, not fighting each other. So I'm going to stop there. Thank you.
Thank you so much. Very nice response actually. Excellent. You have integrated all whatever our discussion very nicely. Thank you so much. So kind of you. So the last question I would like to ask Professor Dr. Bhaskar Sinha, expertise in climate change studies, and as you said, definitely he has brought out very good this Manrega connection between Manrega, climate change and Manrega. That is very. But I want to ask with this question: are there any negative consequences of climate change adaptive practices? If yes, what are those, and how can they impact the ecosystem? Professor Sinha.
Thank you. See, I think the question which you're asking, that is there any maladaptations which is happening as part of the strategy which we are doing it? The answer would be yes or no. But the thing is that how we do it and how much we do it. Okay. So for me, from a practitioner and from management point of view, I think it is important that we should start with the knowledge which we have. We all know that when you are planning any adaptation strategies, it has to be based on a very hardcore science. Science on two aspects. One, that a good forecast, how the climate is going to change with respect to temperature, precipitations, and other variables. And B, what are the likely associated impacts due to these changes of the climate variables. So the question is that you will find all this IPCC report. I mean, I was part of this NatCom, National Communication to UNFCCC, vanilla updated climate division of the ministry. Okay. So it's not that we are not doing. The thing is that, I mean, we also need to focus on the science as scientific aspect until unless you have good quality set of data, a strong set of prescriptions, what is likely to happen, it is then only that can go as an input for planning any adaptation. So we do lack specific data in different sectors, especially the sectors related to natural resource management. I mean, I was responsible for, this as part of the SNATCOM studies, national communication, that impact of climate change on the forest. So if you ask that impact of climate change on forest in India, you'll have lots of data which says that the grid would shift, it will shift by 1 degree. Now, if you go to the people who are managing it, they are saying, what value it is for me? Tell me what is going to happen in my area.
Exactly. Yes.
Okay. So, but to predict that, it's not that easy also. It requires set of data and a lot of capabilities and calibrating. We did that study. So, the thing is that, but the questions they were asking me that, I mean, why didn't you make your study so public? You should have made them that they should accept and implement. And the answer is that, I should be doing that, but they tell me that how much I can do that. Okay. So I think there is a need to bridge this, the so-called scientific community and also the implementation community in the country. And the kind of research which we do, I think this research should be funded and endowed by the implementing agencies. So we should be pretty clear that if you are funding, if government is funding a particular research, who is the end user? So otherwise, I must have done projects worth some 18 crores in last 10 years of all agencies. Okay, some of it, since I'm sitting with IFM, part of the ministry, so some of my things might get hurt, but there would be many more who must be doing far better work than me. But probably, I mean, if they are not in the right kind of alignment with respect to the national policies and programs, their results will end up yielding no value. Times of India published an article that in Delhi, some professor did a research that how many amphibians are killed due to, crossing over by the roads. It took some 3-5 years. They came out that these are the number of, amphibians which was killed, and they must have spent some money. It has no meaning in today's world. No meaning. So I think when we are talking of any such good strategies, planning, adaptation, climate change, or rocket science, or renewable energies, I think it is important that we first frame the right questions in perspective with the right kind of implementation agencies or the programs which government is doing. Otherwise, we are inconsequences. So if our research has to be consequences, as I keep telling to all my researchers, that if you don't ask the right questions, you are inconsequences. So if you are saying 1 degree change, 1 degree change will mean what at what scale? Whether that information is going to be useful or not.
Yeah.
Because everything you are planning is uncertainty. You do not know how much 1 degree will destroy the forest. So what planning? Until unless you know that with 1 degree rise or 2 degree of rise, I mean, this is going to be impact on the soil, this is going to be impact on the teak. It is then only, they can take some measures. And so, I mean, I think that's the first thing. And that record keeping, data keeping, I think that's also very, very important, especially with respect to the forestry sector and also the agriculture sectors also. A lot of things are happening, and it is important that we should learn from our mistakes. When NREGA was implemented, I was part of the professional institutional network from the right day one. Okay, so I have seen all questions coming from all corners. Government was very particular. देश में गरीबी है, सरकार के पास पैसा है, इस पैसे का सदुपयोग हम काम करवा के एसेट्स बनाएगा. आप विद्वान हैं, आप बताइए. If you are a management institute, tell us the solutions.
Yeah.
They're called IITs. You are a technical institute, tell us the technical problem, tell us the technical solution. Don't give me the criticism. Tell us the solutions because we have called you as a partners. They call all the legal institute. You are the legal expert, tell me where the legals. So not that everything is perfect.
Yeah.
Not that everything is perfect, but it has gone through a long journey. If you remember, I mean, there was a payment delay and all kind of things. Now you have internet banking, you have mobile banking. So there's so much of technology also getting interface, and we need to bring to that. And Narega is probably one program which, if you look at that MIS, you will get every dot details, which no program in this country has. So it is not that, I mean, people are not doing it, and we also do not know what kind of information is there. So I think, I mean, there's a gap, if any, I mean, not only with context of the climate change adaptation, for all such planning process, it requires good set of information. And that good set of informations will have to have based on a good scientific principles. And more than that, the good question, the right question, the relevant question. That is the most important things which I think. That what is the questions which you are trying to answer? Is your question consequences? What is your research leading to? What is your information leading to? It is then only if it goes into the input of the planning, planning would be good. If not, in a country like ours, there are many things which we start and we learn from these mistakes. Any institute also to start, there are teaching problems. I still remember when we were debating this MD Narega and other things, people were saying, all those people who were in the government, they were saying that who have retired, oh, such a big program, we should, small is beautiful, we should start from one district, one block. So what country is started with poverty? Go gaga, see, get your feedback, do the corrections. So that is the, I mean, motto, that is the force with which you have to go, and you have to bring in all so-called management or research institute or technological institute, and they have to be on the page for which a solution has to be created. So I think that is the most relevant thing in a country like India, and more so in the forestry sector. There's so much of things which the knowledge is black. We don't have some very specific data to do a good planning.
Thank you. Yeah, very true. Very true, sir. Thank you so much for elaborating this. Yes, the scientific basis actually, and the question what we should pose and what we should respond to. That is very important. How the funding should be used. Yes, sir. So thank you so much to the speakers and panelists. We had very good discussion on gaps and challenges to arrive to a national adaptation plan in India. Based on our discussion, we will prepare a report and submit it to the government. So may I now, at the end of this session, I'm really thankful that I also got this opportunity to conduct the session, and I will call my co-host. Actually, he has done a lot of work in this, Dr. Suha Lama, and a scientist from CSIR Niri Nagpur. I would request him for the closing remark and vote of thanks. Dr. Lama, please.
Thank you, sir. Am I audible?
Yeah, very well, sir.
Good afternoon, everyone. It was an honor to listen to you and listen. It was a very engaging session regarding so many aspects of climate change, environment, and with your expertise, experience, it was a very enlightening session for me. So to go ahead, I just want to summarize because I think we have exceeded a little bit of time, and anyways, we have discussed a lot of it. So I just want to summarize this session in 2 points. Is that for any scientific or any kind of environment related research and projects, the most important thing is data, and that is very established today, and setting up of monitoring stations relating to hydrology, meteorology, even socio-economic data that we have. So data is the most important aspect that rules climate change. So that is one thing that we need to have here for India. And the second thing that Dr. Sinha already has pointed, I just want to quote it, is something called lab to land. To have the research from the lab to then implement it to the land. That will be the most important aspect. So I think these are the two important things that I want to summarize from this session. That data is important, and we have to move our research from lab to land. So to do the formalities, I want to thank a little bit of people. So first, I would like to thank the Ministry of Science and Technology, the Ministry of Earth Sciences, and CSIR, our parent body, for giving us the opportunity to have this beautiful session where we had such eminent personalities speak to us about many things. Secondly, I would like to thank Director IITM and Director Neeri for the guidance and the support for this program. Thirdly, I would like to thank all the participants. They spared a lot of their time and pestering mails from my side. I pestered you with a lot of mails. So thank you very much for indulging us and having such a beautiful session. Fourthly, I'd like to thank all the audience members. I'm not sure how I can see the audience members, how many of us have joined through the link from iConnect, but I am very thankful that they were there to listen to us. And also, this program is never completed without the behind the work team members. So we have a couple of students. Manish is there, who has been the one who's been designing all these questions and the brochures and flyers. So thank you very much, Manish. And also the event managing team from CSIR, who has provided us with the link and WebEx link and the dry run that happened on Saturday. Thank you very much. And finally, I'd like to thank Dr. Milind for anchoring the whole session, even though I was doing the last session, but thank you very much for anchoring for almost 2.5 hours. So thank you very much. And thank you to everyone for joining us today and having such an enlightening session. So we will be compiling all our thoughts into some kind of a policy brief, and we will be circulating it to you also, so that we can take your comments before submitting it to CSIR and the ministry. So thank you very much, and have a good day.
Thank you. Thank you all.
Thank
Thank
you,
you
sir.
so much. Thank you, sir. Thank you.
Thank you. Thank you very
Thank you.
much.
Thank you.
Thank you.